In this lecture, we'll look at simple SQL functions as the first step in learning how to analyze data from a SQL database. SQL includes a variety of functions to perform mathematical, string, and date and time computations. And we'll term these simple functions to differentiate from the aggregate functions that we'll cover in a later topic. Simple functions include mathematical operations like roots or trig functions, string operations like taking in a substring or concatenating or trimming blanks, and date and time functions like finding date and time differences or converting time zones. And by contrast, the aggregate functions we'll cover later perform actions on multiple table rows, like averages or minima or maxima. And before we go into the details, let's cover some basic ideas that apply to all SQL functions. SQL functions are called just like functions in most other languages, with a function name followed by a parameter or parameters in parentheses. And you can use function calls as part of expressions in where clauses, update statements, and as columns in a select. For instance, square root computes a square root, and it might be used thus. We can do a select square root of area from a table called land, perhaps, where the square root of area is less than 10. Or alternatively, an update statement and set the length property of land to the square root of its area, assuming the land is a square-shaped piece of property. And then, even more simply, we can do something like just select square root of 2. And this last one is perhaps most interesting. A select can list more than column values or expressions based on column values. You can use select as a sort of quick calculator by giving just general expressions like this as its arguments and no table at all. That's a good way to test out different SQL functions, for instance. So with that in mind, why don't you use SQL to find the cube of 5, raise 5 to the third power. Now, the point here obviously is to go look up some SQL functions. There's a nice summary in the MySQL docs, and in fact you can find at least 2 ways to raise a number to a power. 3 if you're rather mathematically inclined. Actually run them to get the value before you come back from doing that, and then we'll take a look at potential answers. Okay, so what I came up with are the following. We can do a select pow 5, 3, and that means raise 5 to the third power. It's 125. Or we can select power 5, 3, and again 125. Or, and I'm a bit of a math geek, we can take the logarithm of 5 and multiply it by 3 and then take the exponent of that, and that also comes up, well, with almost the same answer. They all come up with 125 effectively. You may have come up with still others. But note, by the way, that when you run these, the select statement treats the expression like a kind of column, giving it a title, which is just the function that was called, and even indicating that one row was returned, even though there's really no table involved. Since the title is the function call itself, that is sort of ugly. You can rename the column if you like. So, for instance, if we wanted to take our square root of 2 and give it a column name of root 2, we do that. Now, note also that there are 2 synonymous functions, pow and power, for raising to a power. They differ only by name. This is a recurring theme in SQL functions. A number of functions have synonyms, but there's no consistent pattern for this. There's a tan, for instance, but not a tangent for the trig function. This is actually a mark of amateur or old-school design. A hodgepodge attempt to accommodate different abbreviation styles is really what's going on here, and it generally causes more confusion than convenience. Okay, another thing you'll notice about SQL functions is that the language syntax sometimes permits special keywords in parameter lists, since we're kind of going over the big picture here. For instance, to create a string from a set of Unicode characters, we'll touch on this briefly later. Function itself is not too important. It's the example of what it does. You write char, and put a bunch of parameter numbers in there. So it's passed one or more Unicode values, in fact. But the char function accepts as many Unicode values as you want to pass. You put as many as you'd like in there, and it allows an optional keyword using and a character set by which to interpret the values. Again, that's not too important in detail right now, but if you're used to modern programming languages, this is kind of a free-for-all function call syntax. It's a bit odd. And again, that's 1970s design. Okay, with the above background in mind, let's do a tour of the simple functions for numerical values first. And then we'll do string values, and then we'll do date time values. And per usual, we can't go through all of them, so we'll have in-lecture questions asking you to do a bit of background research. We will, however, introduce at least a function or two from each of those areas, and we'll look at the different categories of functions within each area so you know what's available to be looked up when you need it in practice. And from now on, we'll just call them functions, by the way, instead of simple functions. Almost all of SQL's numerical functions fall into three categories. Mathematical functions, just been looking at that, floating point to integer functions, and formatting functions. So, mathematical functions first here. SQL offers a full set of mathematical functions, including powers, obviously, and then logarithms, trigonometric functions, inverse trigonometrics, radian and degree conversion functions, and these all return double results. And while we're at it, all the standard operators like star, plus, minus, and divide are available. And they also count as numerical functions, I suppose, of a sort. So a SQL statement like the one I just put up here, select the cosine of 2 divided by 3 plus 1. If you're into trigonometry, produces that result. Okay, question 2 here. Many modern programming languages provide a modulo, or a remainder operator. It computes the remainder of an integer division. In many languages, for instance, 123% 7 finds the remainder after dividing 123 by 7, and that remainder is 4. So how would I compute 123 modulo 7? How would I get that remainder using SQL? And after a bit of lookup, you might have found as many as 3 different ways to do that. One of them is to do a selective mod of 123 and 7. There's 4, but if you like, you can also, typical SQL here, do it a number of different ways. You can do a 123 mod 7, and you can do 123% 7, just like other modern languages. So, like we said, there's a lot of redundancy in SQL functions. Okay, the next major category are floating point to int functions. And several functions provide floating point to integer conversions of various sorts, like doing a rounding operation, for instance, or more mathematically a ceil or floor operation to round to the nearest integer above or below, respectively. So question 3, investigate these floating point related operations or functions and find a function that will take a positive floating point value, say pi, and truncate it to just 2 decimals of accuracy, rounding as needed. And while you're at it, use a function to get pi itself rather than writing out the value of pi. So the answer here is that if you haven't got the value of pi memorized at 20 places, you can use just pi like that to get the value. And to get it truncated to 2 decimal places, all you need is select and then truncate, and you can pass the pi result straight to the truncate function and put a 2 after that to say 2 decimal places of accuracy, and that'll truncate it to 2 decimals. Okay, our next general category is formatting functions, and several functions are devoted to formatting numbers as strings. For instance, the function format. Look these up and answer these 2 questions. First, format the value 1234567.89 as a monetary value rounding to the nearest cent with comma separations at the 1,000 and million marks. And as a second column, print the value of pi, which we just were using, but to 16 places of accuracy. Again, formatting it as a string. Don't use truncate this time. And what you should come up with is the format function, which I did allude to. And it works a bit like truncate, but it does produce strings, and it also does that nice comma separation that I asked for, so we can get 1, 2, 3, 4, 5, 6, 7 like that. Now, an important point here is that SQL does not necessarily print values to their full precision in general. At its heart, it's a tool for business, not quantum physics. So the select pi that we did a moment ago, for instance, up here, gives only about 6 decimal places after the digit of accuracy. If you want all the digits of a precise number, you've got to format it accordingly. Okay, now question 5. Apply that first format, the one we did here, to the price field of Bakery's product table. And that can be done with a simple select on the product and stuff price into the format function. So what we should come up with then is this. Use Bakery 3. There we go. Okay, and then a few final odds and ends. There are some useful oddball functions that don't fall into any of the above categories. For instance, function rand will return a random value between 0 and 1. There you go. Try it again. There's a different one. If you're generating random permission codes to go into a column, for instance, that might come in handy. So that wraps up our coverage of the math functions, but now that we've seen a few of them, there is one final point to discuss. If you're accustomed to modern programming languages, you'd reasonably assume that only numerical column types can be passed to numerical functions, and that the result of SQL functions follows the usual type rules, for instance, that POW would return a double value. But you'd be wrong. SQL converts between types like a drunken sailor, or JavaScript for that matter. It makes broad assumptions if necessary. So, for instance, if I want to write select square root quote 2.0, that's no problem. In particular, it automatically converts strings of digits or anything else that looks even remotely numerical into numerical types. We also saw this when changing column types in the topic on altering databases, you might recall. Even more alarmingly, if it can't convert a string to a reasonable number, it just assumes it's 0. So the square root of whatever is apparently also acceptable. And if a computation requires conversion into other numerical types, it'll do that too. Question 6. Use SQL to compute the value of, and it's in the notes here, but basically pick a random like 40-digit number and divide it by a random 10-digit number. After you get the result, what do you think SQL had to use as a type to do that huge valued computation? So in the case of the example straight from the notes, we had and came up with that result. The value of the numerator is far larger than will fit even in a double. It automatically used a decimal, in fact, and it did decimal division. Recall that decimal offers arbitrary precision. So in the next segment, we'll look at string functions.